Welcome back to Electric Fantastic. Full Self-Driving, or FSD, is an advanced driver assistance system developed by Tesla that aims to enable its vehicles to drive themselves with minimal intervention. While not fully autonomous, FSD is designed to eventually allow Tesla vehicles to navigate roads, make decisions and handle complex driving scenarios without the need for active driver.
So imagine having a car where you just say where you want to go and the car takes you there. That's what exists today with Tesla. Any Tesla can do this. Let me demonstrate for you. Take me to the Fillmore Heritage Garage. All right, here's where I want to go. And we're off.
It navigates on autopilot. This feature allows the car to autonomously drive on highways, including entering and exiting ramps, changing lanes and overtaking slower vehicles.
So we're in a pretty narrow street. It needs to make a right turn here. You can see in the visualization here, it sees people, it sees buses, it sees everything it needs to make driving decisions.
The biggest AI project on Earth is autonomous driving. And of course, Tesla is in the pole position for that.
According to Tesla, Teslas with autopilot are already almost 9 times safer than the average American driver.
There's no doubt at this point that Tesla's full self-driving technology is on its way to launch a licensed robotaxi program. How do we know this? Well, this week, Tesla released new data about the safety of their autopilot technology, showing that Tesla drivers using autopilot, which includes full self-driving, are 10 times safer than non-Tesla drivers. But today, we'll show you an analysis that shows that full self-driving alone, which includes city driving, not just highway, by itself is already much safer at just 1 crash for every 9 to 15 million miles driven.
I think just based on vehicle autonomy, we can 10x, more than 10x the value of the company. Ultimate ratio of, you say, how many super useful humanoid helper droids do you want? Like, who doesn't want a C-3PO, you know? But a C-3PO plus R2-D2 plus, plus.
Over the last 5 years, the safety of a Tesla with autopilot has essentially doubled.
Wow.
A few months ago, full self-driving went through a significant transformation and had what I consider its ChatGPT moment. All previous versions before it were manually programmed by humans with specific instructions for tasks like object recognition, stopping at stop signs and red lights, how to stay in between the lane lines, etc., etc. But version 12 flipped that upside down and replaced over 300,000 lines of human-written code with an AI model that learns by watching millions of curated clips of good driving behavior and then does its best to mimic that same behavior. It's a monkey see, monkey do approach, and in a way, it's very similar to the way ChatGPT works, but instead of the model outputting text, it's outputting steering, acceleration, and braking controls, essentially making it a kind of drive GPT.
Need to recreate what humans do to drive, which is humans drive with optical sensors, eyes, and biological neural nets. And so in order to, that's how the entire road system is designed to work, with basically passive optical and neural nets, biologically. And now that we need to, for full self-driving to work, we have to recreate that in digital form.
An EV has 20 plus moving parts versus 2,000 plus for an internal combustion engine. EVs have exactly zero maintenance or near zero. By 2030, 95% of miles in America are going to be autonomous, electric, and on-demand.
The data supports what Tesla is doing. 80 to 90% of all accidents on the roads are caused by human error. If you take the human being out of the equation and use AI to get people from point A to point B as safely, as quickly as possible, I think the authorities, the regulators, are going to be persuaded by the data. Autonomous is a SaaS model, software as a service model. Those margins alone are in the 80% range. So it's not just revenues, it is margins that are going to deliver upside surprises. We have Tesla, yes, going to $5 trillion.
You're talking about 5 to 10 years, at some level, an extraordinary long time to be looking out and modeling back.
It will remain our largest position because we think the autonomous taxi platform opportunity is the biggest opportunity from an economic point of view in the next 5 to 10 years, delivering 8 to 10 trillion in revenues in the next 5 to 10 years from basically nothing now.
And you know, a lot of people were saying the Cybertruck is like fake; it's never going to come out. You know, and now we're shipping a lot of Cybertrucks. We hit a weekly record of 1,300. And you know, I think that with the Cybertruck, it really is something special. Like, you know, people sometimes have like different opinions on the Cybertruck, but if you really want to know if something is cool, if it's a great product, like show it to a kid, okay? Like no filter, okay? The kid's got like no filter, like a 5-year-old, 6-year-old, something like that, and or even 3-year-old, and say, which car do you like? Cybertruck. So it's like, that's how you know. It's finally something that it just looks like the future. And it drives so well. You know, it's comfortable. It's just a fantastic product. I think it's our best product, and it's a lot of innovation. It's got a 48 volts low voltage system. Finally, instead of 12 volts, 800 volt drivetrain, the world's biggest castings. You know, it's bulletproof. All the cool things can outpull a F350 diesel, which is a very impressive truck, and it can it can do a quarter mile faster than a Porsche 911 while towing a Porsche 911. So that's insane. So yeah. And if you think about it, like how often do companies make products that move your heart, that are really special? It's so rare, and I think this is one of them. So yeah. And we launched the upgraded 3, which is actually a fantastic car. I recommend trying it out. It's really a great car. And it's only $216 after gas savings, like total cost of ownership. It's basically $200 and something when compared to a gasoline car, a similar gasoline car. So it's really a great deal and a fun car. And the performance, Model 3 performance is, well, it's like, faster than a Porsche 911. It's just a great car. So, yeah. So, yeah. Yeah. And of course, Model Y became the best-selling vehicle globally. And this is something that we predicted. I think I said in like 2022, Model Y would be the biggest car in the world by dollar volume sales, and that 2023 it would be the biggest in unit volume, and it was. Again, this year it will be the best-selling car on Earth. So, yeah. Obviously we've got the Tesla Semi. We're in low volume production of the Tesla Semi, and just last week I approved the plans for volume production of the Tesla Semi. So we're going to make a lot of semi-trucks. We're going to start off with, it's something, I think it'll actually move the needle financially. It's not like, it's not a small thing. And the thing about like commercial vehicles is that companies that use them are super objective. It's not like, it's actually, I mean, obviously we're going to make it have cool style and be an awesome car, but for commercial vehicles, the companies that make the buying decisions, they just look at it and say, like, what are the numbers? Like, is this cost less to transport or cost more to transport than say, a diesel truck? And the thing is that the economics are much better than a diesel truck. It's kind of basically a no-brainer. If you're a transport company, you don't use the Tesla electric semi, you're just losing money. Why would you do that? Do you not like money? Okay. But if you do like money, then I recommend using the Tesla Semi. And so I think this is really going to actually sell at a scale that people will be surprised at, and will actually move the needle financially and do a lot of good. Also for CO2 and sustainability, because semis are driven all the time, actually, even at much smaller numbers, they have a very big effect on total carbon emissions solved. So obviously we've got some new products that we're working on under the covers. And I think these are, I think these are going to be pretty special. So, some of them, I think people maybe at first may think, oh, it's not going to be that amazing, but just wait. It will be. So. So our supercharger network is continuing to grow. Rumors of the death of the supercharger are greatly exaggerated. We are, in fact, continuing to grow the supercharger network significantly. In fact, this year, I think we'll deploy more superchargers this year that are actually working than the rest of industry combined. Just FYI. So now we are going to be more careful about the capital efficiency of where we deploy superchargers. But for sure, any place that has congestion, any sort of missing parts of the map that we're missing, we're going to put the superchargers there. So even for the remainder of the year, we expect to spend about $500 million on supercharger deployment. So it's very significant, and it'd be a well-spent $500 million. So this is, it's a lot. So, and this is actually not showing a bunch of new markets that will be opening up later this year and next. So we're obviously we want Tesla to be worldwide, and there's still a lot of countries that we, have zero to very few Teslas, and we want Tesla everywhere. So. There are a lot of new markets that we're going to open up later this year and next. We're also opening the superchargers to other companies with the that's the adapter to the old somewhat clunky connector. But our goal is to be helpful to other car companies. So any other car companies that are going electric. We do want to be helpful to them with our supercharger network. So we're providing them with adapters and enabling them to have access to the Tesla supercharging network because we think it's better to do that than to create a walled garden that inhibits EV growth. Oops, there was a bit of latency here. And we're also innovating a lot in battery production with the 4680 that's built right here. It's a hard problem, Like there are entire companies that just make battery cells. That's all they do. But we're making good progress. Like all the Cybertrucks that you see use the Tesla 4680 cell. We have a clear path to the 4680 being, we think, probably the most competitive cell from a manufacturing efficiency standpoint. And so it is a hard problem, I have to say. There's quite a lot of brain damage required to be good at cell manufacturing. It's like a brain damage high. But I think it does give Tesla resilience in the face of if there are changes in the, I don't know, geopolitical situation somehow. But it's good to have some independence in cell manufacturing. Yeah, and we're making steady progress, and we also have the cathode refinery, which you can see behind the main factory. So you can sort of see it in the picture there. That's a cathode refinery, and then we've got the lithium refinery in South Texas. And so we're just making sure we've kind of got the pieces of the puzzle. And I mean, if you were to look at sort of a video of how Tesla does, say, cathode and lithium refining and how the rest of industry does it, it's night and day. I mean, you can sort of eat off the floor in the Tesla refinery, and I would not recommend doing so in the others. So, you know, we're definitely going very, very vertical here. But I think this is it's a wise investment that will pay off more than people realize. So. I don't think this thing's working. So this year, we're also on track to complete a massive number of energy deployments. So that is a gigantic increase in deployment capability. We seem to be tracking to sort of a 200% to 300% year-over-year growth in energy storage deployment in stationary pack. So it's giant. And the limiting factor really is being able to build more megapacks and build more Powerwalls. So we're ramping up production of the Powerwall 3, which is really a game changer for at the personal level. The Powerwall 3, it usually takes about 3 iterations of any given technology to really for it to be something where it's like, okay, now we're really hitting the sweet spot. So Powerwall 3 is like an epic product. The Megapack is also, I'd call it sort of iteration 2 of the Megapack is also an epic product. With the Megapack 3, which is, I don't know, probably a couple years away, we'll start actually absorbing more and more of the substation of the sort of power electronics. So, because I sort of think you want to get to the point with the Megapack where you can literally just take the high voltage power lines and plug them in. There's no substation. We just plug them in. Just drop them down and drop it down and plug it in. And now it works. Which is like mind blowing for the utility industry, by the way. Like, they're like, what? Yeah, you just plug the wires in and it'll work. For very high voltage. So that I think is actually going to be a major. So this is anyway. So yeah, this is great. Excellent work by the energy storage team. So. Services and other are also looking good. So we're actually now making money on the services and other stuff. So this is kind of a big deal. Right? Yeah. So let's see. Yeah, and Tesla's obviously way more than a car company. We do a lot of software at Tesla. About, I don't know, roughly half or a very huge percentage of the engineering we do is actually software engineering. So Tesla's, I'd say, as much a software company as it is a hardware company. This is a very big deal because car companies are not software companies normally. So this matters a lot. So things like our orbiter software for energy storage, all of the software that controls the cars, the megapacks, the power walls, the solar, obviously for AI and full self-driving are a big deal, insurance, service and collision. Tesla also writes a lot of software internally that helps, that like we call like the Tesla operating system internally, that is head and shoulders above what any other company has. I think probably better than any Fortune 500 company. The Tesla internal software is just way better. So it's just far more than what people normally think of as a car company. And Tesla is also the leader in real-world AI. So there's really, this is a big deal. Like Tesla is ahead of Google, Meta, OpenAI, anyone on real-world software, actually taking in video and making decisions based on video. No one is even close. And it's getting better, I'd say, with each passing month, if not each passing week. So, yeah. And it's also worth noting that Tesla is actually pretty good at chip design. So the AI inference chip that was designed by Tesla that's in cars, we had sort of our hardware 3 AI inference cars made over the past year have the hardware 4. We've just completed design on hardware 5, which we're now calling AI 5, because it's really is. There still actually is not a chip from NVIDIA or from, and I have a lot of respect for NVIDIA, from any company that we would prefer to put in our car that is better than what we have in the car. So, we started from scratch in chip design, just as we started from scratch in AI software, and have the best real-world AI software and the best AI inference chip in the world from nothing. So this is, a big deal. And the capability of the chips in the car is dramatic. Like, I mean, right now, all the cars are actually training. Like we have hardware 4 run hardware 3 in emulation mode. So we'll continue to make significant progress on hardware 3, but later this year we'll actually bifurcate, continue working on hardware 3, so on training on hardware 3, but then do separate training on hardware 4. That'll be the sort of training cluster that we're building at the south side of the Gigafactory, and that'll be dedicated hardware 4 video and inference, and. So the hardware 4 has cameras that have about 4 or 5 times better resolution, and depending on how you count the sort of hardware 4, it's about anywhere from 3 to 8 times better than hardware 3. So, but everything you're seeing thus far is just hardware 3, and we still have a long way to go before we reach the limits of hardware 3. So hardware 3, I think will do amazing things, but hardware 4, I think will probably do about 5 times better. Then hardware 5, which comes out in about 18 months or so, is 10 times more capable than hardware 4. It's like sort of, if you know NVIDIA hardware, it's sort of a B200 class computer. That's like this. So what we'll just progressively do is improve how many nines of reliability the car gets, and then of course that will go into Optimus as well. So the same chip will go into hardware 4 will go into is an Optimus. Hardware 5, AI 5, which we're calling switching from hardware 5 to AI 5, will be in Optimus and in all cars in about 18 months. and it's really just a staggering amount of compute, and it's very power efficient compute. So it's got to be, because if you're in a mobile application like a humanoid robot or a car, you can't just be sucking down 10 kilowatts, like you can in a data center. So you've got to be very power efficient. So the sort of hardware 3 and 4 are only a few hundred watts. Yeah, this is hard. Now, hardware 5 will be able to go probably up to about 700 or 800 watts, but it'll power fluctuate contingent upon the complexity of the scene that it is in. So if it is in a parking lot stationary, it's like you don't have to think very much. Just like a person. Like if you're in a complicated traffic scenario, you've got to think a lot more than if you're just cruising along, on an empty road. But something that I think is potentially interesting down the road is, like at some point, the Tesla fleet, I think, will probably be, over 100 million vehicles. And if each vehicle has a kilowatt of efficient inference compute, I think there's an sort of an Amazon Web Services, AWS type opportunity, because if you've got 100 million vehicles with a kilowatt of efficient inference compute, you've got 100 gigawatts of compute. Like 100 gigawatts of compute is a lot, and it's distributed all over the world. So when the car is not in autonomous mode, which I think probably is, or doing robotaxi work maybe 50, 60 hours a week, but about 100 hours a week, it's not, it's probably stationary. So there's 100 hours of 100 gigawatts of inference compute, which I think we should use. Why not? When people looked at Amazon, which started out obviously as an online bookseller, and it's on, has grown to be like this incredible place where you can buy anything, and then Amazon Web Services, like, well, they got all these computers that only really see peak usage sometimes, but what are they going to do when it's not peak usage? And sometimes the Amazon servers are down like 10%. So that's when they said, well, let's do Amazon Web Services. And then Amazon Web Services became more valuable than the entire rest of Amazon. And I think there's some kind of opportunity there that's pretty significant for Tesla down the road. Again, that's really, nobody's really factoring that in. But I think that actually will be quite significant. We also are no longer compute constrained for training. So I check in with the team. It's like, is there anything we could do to improve the pace of progress with respect to training and inference? And currently that is not the limiting factor. In fact, the limiting factor right now is that the amount of miles between interventions is so long that it takes quite a while to figure out which version is better than the other version, because none of them are requiring any interventions. So it's like, if you start getting to like thousands of miles between interventions, or you're like 10,000 miles to get an intervention, then the average person only drives about 10,000 miles in a year. And if it's in an urban environment, and the average speed is 20 miles an hour, so our professional test drivers get pretty bored, frankly. They're like, okay, I drove all week and there was no intervention. Like the highlight of the week would be like, yes, an intervention, finally. It's like getting to that point. So this is where actually having a giant fleet is extremely important, because we can deploy a new FSD model and run it in shadow mode and see how well it performs. Compare how the human drives the car versus the new self-driving build, and then analyze that delta in shadow mode, like the shadow knows, or doesn't know, as the case may be, and then be able to assess by getting billions of miles very quickly with the giant fleet. Like that, basically, that data engine is incredibly helpful. Like, actually, it's not possible to solve the self-driving problem without having millions of vehicles on the road. So, so that's actually is like figuring out clever ways to test how good the next build, FSD build is actually the limiting factor right now. And then, of course, like I said, we are building another training data center right here, which will be dedicated to Hardware 4 training. So we'll bifurcate Hardware 3 and Hardware 4 training later this year. We'll keep improving Hardware 3, but we're going to uncork the full capability of Hardware 4 as well. So, yeah. And I think most people here have tried out version 12. We did say, like, unsupervised full self-driving would be version 12. So we are actually just keeping the version arbitrarily at 12, and then like calling it 12.4, 12.3, 12.4, 12.5. But it's actually really like version 13, version 14. But anyway, this is an arbitrary designation. So 12.4 is actually like a whole different version than 12.3, and 12.5 is a whole different version than 12.4. So you'll see really giant improvements, I think sometimes factor of 10 improvements between successive versions. And then, as I mentioned, the way it'll work for the existing fleet is you'll be able to add or subtract your car to the fleet as you'd like. And there will also be Tesla-owned cars. So it'll be a combination of like Uber plus Airbnb. But it'll be pretty wild that there'll be a software update, and then the whole fleet suddenly becomes accessible. It's like suddenly you've got 7 million, 10 million cars that can, ultimately tens of millions of cars that can do autonomous driving, and instead of being used 10 hours a week, can be used 50 or 60 hours a week. So it's pretty wild to just be in Palo Alto with a bunch of cubes, and then a humanoid robot just walks past. We've made a massive amount of progress with Optimus in a short period of time, from someone pretending to be a robot dancing in a suit, to a pretty hodgepodgey robot, to a robot that is actually doing useful tasks in the factory today. So we have 2 Optimus robots in our Fremont factory that are doing basically this task, which is taking cells off the end of the line and placing them in a shipping container. And yeah, we actually have quite a few of these cruising around our offices in Palo Alto. So there's, and I think we've got kind of like one major hardware revision, which should be done by end of this year or early next, and then we'll move into a limited production next year of Optimus. Limited production for use in our factories, where we'll test out the product, kind of, as I say, sort of eat our own dog food or whatever the electronic equivalent of that is. But I think like next year, my prediction is next year we'll have over 1,000, maybe a few thousand Optimus robots working at Tesla. And things are going to scale up very rapidly from there. So we'll iron out the bugs. Like the degree of autonomy will be radically better. You'll just literally be able to talk to it and say, please do this task, or I'm going to show you something. Now do the thing that I'm showing you. Get to the point where it can watch a video of something like a person and then learn just by looking at that video and do that task. So, yeah, So really, it's going to be quite something. And I'm confident of the prediction that there will be more, like the ratio of humanoid robots to humans will be greater than 1 to 1. So that there'll be, more than 10 billion humanoid robots in the world, probably 20 or more. And Tesla is going to be by far the leader in that. You're seeing a lot of robot startups, but I think it's actually very challenging to do Optimus as a robot startup, because what we found, to make Optimus work, we've had to design from first principles, from scratch, every part of the robot. So the motor, the gearbox, the sensors, the power electronics, the communication system, everything had to be done from scratch. We found that there's basically nothing. There's no supply chain. So even though there are many electric motors made in the world, there's no supply chain for the types of motors and sensors and gearboxes that are needed for a humanoid robot. And what you're seeing here is our current generation hand and arm, but our next which has 11 degrees of freedom. Our next generation has 22 degrees of freedom. It will be able to play the piano. So it's really like, wow. Now, of course, like I said, we need to make sure we don't have the Terminator scenario. That's very important. Safety of the humanoid robot will be very important. But because it requires so much ground-up designing every motor, gearbox, sensor, power electronics from scratch, it's very hard for a startup to, if not impossible, for a startup to replicate that. But at Tesla, we have the world's best electrical engineering. I think we've got the world's best mechanical engineering for gearboxes and for electric motors, power electronics. We have the resources to do that. It applies quite well. And then you also have to have the brain. You need a power-efficient inference computer, which we've got for the car, and we'll be using an Optimus. You need AI. You need to be the best in real-world AI, and Tesla's the best in real-world AI. So you need all of these. You need a very strong hand of cards in order to make a compelling robot. And then you also need to be very good at scale manufacturing. So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000, you actually need to design for manufacturing and be very good at manufacturing. And in my experience, prototypes are easy compared to volume manufacturing. Prototypes are easy, production is hard, relatively speaking. So Tesla has the production capability, it has the engineering capability, and it has the AI hardware and software capability. And even the most optimistic estimates that I've seen for Optimus, the optimist, I think undercount the magnitude of what this robot will be able to do. As I said at the beginning of the presentation, I agree with the ARK Invest analysis that autonomous transport is called sort of a $5 to $7 trillion market cap situation. Optimus, I think, is a literally $25 trillion market cap situation. So. Now, I don't want to trivialize what's necessary to get there. I mean, it's an immense amount of work that is required to get there, like super difficult. But we are moving very fast down that road, and we're going to make it happen. So, thank you. I guess with that, we can go to Q&A. Sorry? Yeah. I guess we've got mics lined up. Dive for the mic.
If you have a question, feel free to. Hey, Elon. Last year, I thanked you for making the world a better place for my son to live in. And I wasn't clear. In particular, I was referring to what you've done for the First Amendment and our rights.
Thank you.
History will not forget it, and the sacrifices you made and the risks you took will pay off and have paid off.
Thank you. Yeah. Well, I very much appreciate that. I think you have to say, like, why was the First Amendment so important? Is because, people came here from places where if they spoke their mind, they'd be put in prison or killed, or just shut out from society, ostracized. So freedom of speech is absolutely fundamental to a good future. And yeah, that's the reason for, acquiring Twitter and trying to, just making it a free speech platform. I think it was very important to just the future of civilization. So, thank you.
Hey, Elon. My name's Ronnie. I'm on your right side. How's it going? Hey. I work for Tesla sales in Orland Park, Illinois, and I was always wondering, do you think Tesla could ever move forward towards bundling software as like a package to, possibly increase take rate for FSD, maybe bundle it with premium connectivity and future software options?
I think we definitely want to encourage people to try FSD, and one of the things that I think probably makes sense is that when we have a significant improvement, every time we have a significant improvement in FSD, give all customers a 2-week free trial. So like, hey, we've made an improvement to FSD, try it for another 2 weeks. With 12.4, we finally get rid of the steering wheel nag, which I know is driving people crazy. Yeah. Thank heaven for small mercies. Even just something like that, not having the steering wheel nag, and obviously having a far lower intervention count, far more miles between interventions. So I think keep sort of offering people free trials of FSD every time we make a significant improvement. Okay.